Okay, welcome to the lecture here on global warming, beliefs and evidence. So this lecture is supposed to give you general background on global warming, and specifically we're going to have you think about the kinds of ideology and other factors that influence whether or not people believe in global warming, and then we'll talk about some of the different kinds of evidence for global warming, and then look at the consequences. So just FYI, you should be taking notes as you go on this. There are some slides that are missing from the pages that I gave you to print out, just to save you paper. So if there's a missing slide, make sure you still write down information about it. And you can adjust the speed at which you watch these videos. So if you want to have me talk faster so that I sound like some kind of crazy squirrel, you are welcome to do that. Okay, this is a famous mountain, the Matterhorn. It straddles Italy and Switzerland. It's part of the Alps. And this is a picture that was taken from a plane, I think back in the 40s. And then there was another guy recently that said, hey, I want to see what this looks like from the same angle, same kind of cloud conditions. And so went up just a few years ago. And you can see the difference here. So lot of melting of the snow and the glaciers around it. Huge difference. So that's just an example of one iconic set of pictures that captures the changes that are happening on the Earth. Okay, so the lecture outline, just FYI, if it's in this kind of goldenrod color, you don't need to write all this down. This is just giving you an outline of the things we're going to talk about. So it's like a preview. So first we'll talk about the beliefs, then the historical context, some evidence and consequences, and then what I call sense making. In other words, the various factors from politics, psychology, ideology, industrial history that shape the way we understand global warming. Okay, so here's an interesting graph. This is from the Pew Research Center. They conduct different kinds of surveys, and it's a well-known independent philanthropic organization. And they've been looking at attitudes on global warming since at least 2006, as you can see here. So what you should notice is on either of these questions, the first one, percent saying warming is caused by human activity, and the second one, percent saying global warming is a very serious problem, we see huge differences based on partisan affiliation or ideology. So this one goes from dark blue to dark red, from liberal Democrat, conservative moderate Democrat, moderate liberal Republican to conservative Republican. We see there's these big gaps here from 76 to 15% and here from 76 to 14%. So this suggests if you ask people, do Americans in general believe in global warming? You have to answer, it depends. It depends on their politics. This kind of gap, it's not unusual to have a gap based on ideology and different kinds of beliefs, say like the effectiveness of gun control or how important is government regulation. But a gap of this magnitude is rare. So we know that this is a highly charged ideological issue. You can also think about religious affiliation as a close cousin or type of ideological identification. And here we can see as you move down this chart, what happens in different groups of religious folks. And we can see there's a pretty big gap here between unaffiliated. So these would be your atheists, agnostics, or people that don't claim any religious tradition. 58% thinking global warming. There's solid evidence for human-caused global warming versus just 34% of white evangelicals. So second point here, religion is something that appears to structure or influence or at least represent differences in beliefs about global warming. And here we have another Pew survey poll from 2015, and this is asking people to say what their priorities are. So they may believe in global warming, but how does it stack up against other things? And we can see it stacks up pretty badly. It's down here way at the bottom. Underneath things like transportation, energy, tax reform, moral breakdown. It does beat global trade. Not sure how much solace to take in that victory, but very few people are listing it as a public policy priority. When you ask scientists, they might say that it could end life as we know it. You would think it would rank a little bit higher, but it doesn't. What does draw people's concern? Well, if you look about here in the West, that is like the US and Europe, the top rated threat concern from 2015 is ISIS. So ISIS is something that gets a lot of press. It's a terrorist organization. But when you think about the number of people that can be affected by ISIS and the number of people that can be affected by global warming, it's probably an order of magnitude difference of, I don't know, 100 times more threatening what we're faced with global warming than ISIS. But ISIS triggers some, we'll talk about this later in the course, some evolved dispositions to be concerned about other groups that might have it in for your group that have a different religious or ideological orientation than your group. And we're hypersensitive to those kind of threats. We're not hypersensitive to climate change, since that wasn't something that we experienced on a steady basis in our evolutionary environment. So our brain isn't really wired to think about that as threatening. Another perspective here is, how do people think about global warming versus scientists? Well, you can see, and I think, I don't have the date here, but I think this is from around 2009, that there's a pretty big gap. Scientists, 84% say it's warming is due to human activity. 49% of people, the public, say it is. And this is one that's even more interesting, I find. It's comparing what people in the public think scientists think. So it says 56% here of the public think that scientists think that global warming is being caused by human activity, when it's actually 84%. So in other words, people are pretty clueless, even after all these years of education, about what scientists think about evolution. And you can notice this maps closely onto the same gap you find with evolution. And then another interesting survey they did is they looked at the political affiliation among scientists. So they found that only 6% of scientists, and they're talking about primarily hard scientists here, you can see down here the four groups, but only 6% are identifying as Republican, and that's versus 55% identifying as Democrats and 32% independent. Now, you might say, wow, that's just those crazy, wacky, liberal college professors. But if you look here in terms of where these folks work, even if you look just in industry, in other words, folks that are employed by corporations, only 10% of them are identifying as Republican. So what's going on here? There's other data, I'm not going to go into this now, that suggests that the Republican Party has become much more conservative in the last 15, 20 years relative to any shift in the Democrats. And certain positions they've taken in terms of global warming and evolution might play some role in that, in some kind of resistance to scientific information. Okay, and the point here is not to pick on Republicans, but this should suggest that there's a huge influence of partisanship and ideology in affecting how we think about crucial issues like global warming. Okay, so what's the relationship of psychology here? This is just a little aside, but to make the point that this is all relevant to psychology, first, it's human behavior that's causing global warming. You can define that in different ways, but just the simple desire to have children, especially more than one or two children, has a huge impact on the planet if you model that out over a certain number of years. The kids are going to grow up and drive cars, eat meat, want to live in large detached suburban homes and use electricity. So just the fact is, at the end of the day, it's human behavior that's causing the problem. So there's two levels you can think about this at. One is that psychologists can help change specific behaviors. So we can get people to set their thermostats lower or get people to take public transportation. And you can also think about, maybe with a little more sophistication, some things like, well, folks are trying to set themselves apart from other people and show that they're successful. And we'll talk about this as an evolutionary drive, especially among men, to show that they have achieved a certain status or a certain positional status and where they're above other people, and that will drive certain kinds of consumption to demonstrate that they have reached that level of success. So we can examine some of those kind of things, but we can also, here at the third point, look at critiquing the status quo and digging in a little more deeply. So, for example, we can think about the ideology that structures people's understanding of global warming. One of those ideologies being authoritarianism, and another one being the social dominance orientation. And then also we can think about examining political power more generally. In other words, looking at how corporations and other actors might want to shape different people's attitudes about global warming. And psychology, along with political science and sociology, can help us think a little more critically about how different discussants are trying to shape the dialogue about global warming. Okay, so the historical context. It's important that you understand that the very perspective or some basic assumptions that you start with can really influence how you think about global warming. So I'm going to just real quickly review the basic earth science involved, but then suggest that we might think about the human species as a natural phenomenon, as something that the earth came up with, but that it's a relatively new phenomenon. So the humanity is kind of a new behavior of the earth that started relatively recently, and it's not really field tested. It hasn't been around long enough to know what kind of consequences it's going to have. So we'll have that deep historical perspective, but we'll also think about how things have changed since the advent of the Industrial Revolution, which some people call the fossil fuels revolution, because it was largely the use of fossil fuels that made the industrialization of the global economy possible. Okay, so first point. Global warming is something that we certainly need, or else we would all very quickly freeze to death. So the sun throws out a bunch of heat. Some of it bounces off the planet, and if we didn't catch some of that heat as it bounced off the planet, there wouldn't be enough absorbed, and we would all freeze to death. So it's good that there are greenhouse gases like carbon dioxide, nitrogen, and methane that are going to bounce back some of that radiated heat to the planet. So this is like a blanket that you keep on at night to keep you warm. But the problem is we've been steadily adding to these greenhouse gases, so this delicate balance that's maintained the temperature as it's been for thousands of years is getting messed up, and we're slowly adding more greenhouse gases here, so that we're slowly heating up the planet, and that's going to have some nasty consequences. Okay. Second point, we want to think about the population explosion, and I'm going to show it to you in one of two ways. Here's the short view. If you look from 1750, so that's about the Industrial Revolution, up till 2000, and then they're projecting out more billions of people being added. Not so much in the developed countries, but in the less developed countries. There's this kind of population explosion. But if you look just from this perspective, it doesn't look that bad. But if you adopt a longer view, kind of from the perspective of the Earth, and go back into the Stone Age, 2.5 million years ago, it starts off pretty small in terms of human population, and then it starts growing. And you understand here that there is this spike that occurs, which looks like somebody's having a heart attack, right? There's a little dip here at the Black Death during the Middle Ages. And then there's this huge growth. And so if you project out to 2025, we're going to have lots and lots more people, billions of people on this planet. So one idea or one metaphor that might help you grasp this is there's the 6-day week model of evolution. Now, this is not a creationist model, but it's taking that idea of 6 days as a frame of reference that we all are accustomed to because we understand how long a week is, and that makes kind of sense to us at a gut level. So let's do this. Let's start imagining that life came about in the most basic kind of little blob of stuff form on Monday morning at 12:01 or 12 midnight, and then it keeps going and going and going until the present day, which would be Saturday night at 12 midnight. So the question is, when do modern humans arise? In other words, Homo sapiens sapiens. You might be surprised, or you might think, well, maybe they came about like on Wednesday or Thursday or Friday. It turns out that they didn't come about until 11:59 and 49 seconds. In other words, with only 11 seconds left in the week. And recorded human history, so from the code of Hammurabi and um, original civilization in the Near East, that has only been 2/3 of a second. So that suggests to us that when we think about the world as being kind of humanity's playground, humanity is a pretty recent addition to the ecological mix that has comprised the planet. And so it's as if you're driving in a car and everything's going fine, and then all of a sudden you hit the gas, and for the first few seconds everything seems to be going okay. But that's really not a good indicator of the long-term consequences of hitting the gas and holding it to the floor, because just a few seconds you won't see the full long-term consequences of it. So to make that point, one way of thinking about this is humans equal a certain kind of drastic change. So going back not too far, a little before the 1800s, up to the present day, you can see a pretty drastic decrease in the number of acres, millions of hectares of tropical forests. More generally, if I were to ask you what percent of all the forests that were once on the planet are still on the planet, we're down to 50%. So we've already lost half of what was on the planet. And what that means is when you and I are born, we look around and say, okay, there's about this many forests. And then 10, 20 years go by and we're like, yeah, all right, we still got a lot of forests. But we don't realize our ancestors have already done a lot of chopping and burning and clearing of land. And that forest is important, obviously, because that's where you have the capacity to absorb carbon and keep it out of the atmosphere. And the more you cut down those forests, the more you're going to put it up in the atmosphere. Okay, so a few more background facts. The U.S. is the leader in fossil fuel production. You can see that here. We handily beat any other country. And that's a problem. But if you look here at India and China, they're not putting out nearly as much as us. But let's look at this. They have a lot more people than we do, some 3 to 4 times as many people, each of them. So we're around 300 million now, and India and China, they're putting it over 1 billion people each. And this is in 2006, so these numbers are out of date. And there are already more people there. And the idea is once they start living like Americans, wanting to eat meat, wanting to drive cars and live in big houses, the impact on the climate is going to be drastically larger. So let's shift gears now and think about time in a shorter frame, when the Industrial Revolution began. And I have the arrow here pointing, somebody goofed up. It should be pointing a little more up here at 1750. But at any rate, you see there's this beginning of a curve where it's flat in terms of carbon emissions, and then it starts going up. So carbon emissions, that comes from burning oil, burning coal, gasoline, all that stuff. And as the emissions of carbon go up per year, big surprise, the CO2 concentrations, carbon expressed as a gas in the atmosphere, goes up. And then pretty closely, what's tracking that? Temperature. Now there's yearly variation based on El Nino and other kinds of things, but by and large, as carbon emissions go up, carbon concentrations go up, which causes temperature to go up. So what do we mean when we say fossil fuels? We mean overall, here's the total. You can see it's still clearly going up. But we can break that down into petroleum, which we get gas that drives our cars, we get coal, and we get natural gas. And then down here also is cement production, which most people don't realize, but that also contributes substantially to carbon output. So it's still increasing, and these are some of the different kinds of carbon that we have. And then what does that mean? That means that we're putting more greenhouse gases into the atmosphere. So here we have carbon dioxide and methane, both are greenhouse gases. And we see that from back in the day, in the 1700s, it's starting off and then we're increasing drastically, and the same thing with methane. And to get an idea of what the temperature was back in 1700, 1800, they go to cold places where there's a long record of compressed ice, And if they dig down, they get samples that go back in time, so to speak, so they can look at what the air was like at these different years, and they can then plot what carbon is and what methane is. And then more recently, we're measuring things from observatories. So like there's an observatory in Hawaii that tracks the carbon in the atmosphere. And combining these two data sources, we can plot these curves. So if we go back even further, you can see that it's pretty steady for a long time. And then we have around 1800, after the Industrial Revolution starts off, we start getting this increase. And this is showing data collected both from Antarctica and Greenland. And it's important that you have both of those, because one of those is on the top of the planet, so to speak, Greenland, and one is near the bottom, Antarctica. So that suggests, because they track together, that it's a global phenomenon. It's not a local aberration. So more specifically here, and I don't think I gave you these slides, but they show the same pattern. You've got the greenhouse gases from the ice cores and then the modern data combined. And if you go back 10,000 years, it's flat, 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 and then boom, there's the spike. Again, we want to understand that there's a difference in terms of what a long time is. We might think about this scale up here as being adequate, but from the scale of the Earth, we can see that this is much more, again, like a heart attack. So we see this with carbon dioxide. We see the methane going flat and then spiking, and then we see nitrous oxide, and nitrous oxide that comes from artificial fertilizer made from nitrogen. And so primarily different kinds of farming practices that produce that. Again, but largely flat, and then boom, this spike. So summarizing the historical stuff there. One, you've seen this population explosion. Historically, it's happened, and with China and India and other countries with booming populations, you're going to see even more carbon output. And we want to think about humanity as a new phenomenon on the planet, try to step away from our human-centric view and think about from the planet's view, and recognize that humans have really made some big changes, especially since we've got to the Industrial Revolution. And then we showed you various graphs there to show you what's actually happening with the greenhouse gases, and that there's been an explosion. From the Earth's perspective, it's a sudden onset of some pretty drastic changes. All right, next we're going to turn to the evidence and consequences. I think I'm going to stop here at this point and put this in a separate lecture so the file doesn't get too big, but this is where we'll pick up.